So we're continuing to talk about function notation to perform operations, and so we're going to focus now on multiplying exclusively in this video, and the next one will be about dividing. So the same idea applies here. When I say f times g of x, I mean multiply together f of x and g of x. So I'm just going to write the expression x squared minus 9 times x plus 3, okay, and I'm going to FOIL this out. So this is x squared times x is x cubed. X squared times 3 is 3x squared. Okay, negative 9 times x is negative 9x, and I get a negative 27 at the end. This is actually my answer because none of these terms combine with each other. When I'm talking about the domain of this resulting function, I need to look at each of my beginning functions and say, is there anything that I'm not allowed to square? And in this case, I can square anything I want, and I'm going to get an answer back. So I'm going to say the domain of f of x is all real numbers, and then the same thing is going to apply to g of x. I can add 3 to everything, so I'm going to say the domain of g of x is also all real numbers, which means my new function, this one, is also going to be all real numbers. Okay, so just to show you some more examples, I'm not going to continue to do the domain and range because we're going to use f and g for all of these functions, which means everything's going to be all real numbers. So we're just going to focus on the multiplying part. Okay, if I said g times g, I just mean actually repeat g times g. Okay, and this comes out to be, you know how to FOIL this out, x squared plus 6x plus 9. So you can multiply a function with itself. Okay, so that's another example. In this particular problem, I'm doing multiplication, but I'm doing something called scalar multiplication. And that's when I multiply a function just by a number, by a single number like 4. So what this is basically telling me to do is take 4, multiply it by f of x, okay, get that answer, do the same thing and do 3 times g of x, okay, which my g of x I have up top is the x plus 3, so I'm going to plug in an x plus 3 here. Okay, so I'm now just going to distribute the 4, okay, and I'm going to distribute the negative into the g of x function, okay, and then I'm going to combine anything that combines. So in this case, it looks like 4x squared, negative 36 minus 9 is negative 45. Let me put the 3x first, and then we're going to subtract 45. Okay, so you can multiply numbers by functions when the 4 is right before the function itself. Okay, the last one, I'm asking you to do f of g like I did up here, but instead of putting x, I actually put a number in this spot. So I'm actually asking you to plug in to f of x and plug into g of x the same thing. So here's what I want to show you with this one. When I have f times g of x, I have two options. I could take 3 and I can say, let me do f of 3, which is 3 squared minus 9. Well, that's 9 minus 9, or 0. Okay, I could do g of 3 as well, and that's going to be 3 plus 3, which is 6. Okay, and then I could multiply the results together, and I could say, well, that means that f times g of 3 is really equal to 0 times 6, which is 0. Right? So you could evaluate each of the functions and then with the 3 and then multiply them together, or I could multiply the expressions together like I did right here. Right? If you notice, this resulting function here is g of x, right? It is f times g of x. So if I were to plug in 3 into each of these expressions, let's find out what happens if I do it to the f times g of x expression. Right? So we're going to do that off to the side here, and I'm going to say, okay, I'm plugging in a 3 into this new function. So it's 3 cubed minus 3 times 3 squared minus 9 times 3 minus 27. So let's find out what happens. Well, 3 cubed is 3 times 3 times 3. That's 27. Okay, this is 3 squared times 3, so this is minus, that's 9 times 3 is 27. Okay, this says minus 27, minus 27. Okay, so we're going to multiply these expressions, or subtract these expressions. 27 minus 27 cancels, okay, and 27 minus 27 cancels again, and I'm going to get a big 0. Right, so if you take a look, I'm getting the same thing. Here's my mistake. This was a plus sign. I was looking for the plus sign in this problem to figure out why I wasn't getting that cancel happening. Okay, so 27 plus 27 is 54. Okay, negative 27, if I do minus 27 minus 27, it's going to cancel out my 54, and I'm going to get that 0. Okay, so It doesn't matter if you plug in to each of them separately and multiply the results, or if you just multiply these together, get an algebra expression, and then just plug in one time. So you have that option. Both of them will work. Sometimes it's easier to do one, sometimes it's easier to do the other, and the option is entirely up to you.